Welcome, ladies and gentlemen, to an exhilarating journey into the world of aeronautical propulsion. Today, we invite you to fasten your seatbelts as we delve into the fascinating realm of Ramjet engines, the fiery hearts that power some of the fastest flying machines known to mankind. So what is a ramjet basically? A ramjet, or athetid aerothermodynamic duct, is a form of air-breathing jet engine that uses the forward motion of the engine to take in air for combustion that produces jet thrust. Since it produces no thrust when stationary ramjet-powered vehicles require an assisted takeoff like a rocket assist to accelerate it to a speed where it begins to produce thrust. Ramjets work most efficiently at supersonic speeds around Mach 3 equal to 2,300 miles per hour and can operate up to speeds of Mach 6 equals to 4,600 miles per hour. Ramjets can be particularly useful in applications requiring a small and simple mechanism for high-speed use, such as missiles. The US, Canada, and UK had widespread ramjet-powered missile defenses during the 1960s onward, such as the CIM-10 Bombark and Bloodhound. Next is scramjet. It is a variant of the ramjet, but a scramjet relies on high vehicle speed to compress the incoming air forcefully before combustion. But whereas a ramjet decelerates the air to subsonic velocities before combustion using shock cones, a scramjet has no shock cone and slows the airflow using shock waves produced by its ignition source in place of a shock cone. This allows the scramjet to operate efficiently at extremely high speeds. Unlike a typical jet engine, such as a turbojet or turbofan engine, a scramjet does not use rotating, fan-like components to compress the air. Rather, the achievable speed of the aircraft moving through the atmosphere causes the air to compress within the inlet. As such, no moving parts are needed in a scramjet. In the flight of the experimental scramjet-powered Boeing X-51A, the test craft was lifted to flight altitude by a Boeing B-52 Stratofortress before being released and accelerated by a detachable rocket to near Mach 4.5. In May 2013, another flight achieved an increased speed of Mach 5.1. Standing oblique detonation ramjets or SODRAMjets replaced the diffusive ramjet combustion with an oblique detonation. During the Cold War, the US made and tested a nuclear-powered ramjet called the Project Pluto. This system, intended for use in a cruise missile, used no combustion. A high-temperature, unshielded nuclear reactor heated the air instead. The ramjet was predicted to be able to fly at supersonic speeds for months. Because the reactor was unshielded, it was dangerous to anyone in or around the flight path of the low-flying vehicle, although the exhaust itself wasn't radioactive. The project was ultimately cancelled because ICBMs seemed to serve the purpose better. Next is the Bussard ramjet, which is a theoretical method of spacecraft propulsion for interstellar travel. A fast-moving spacecraft scoops up hydrogen from the interstellar medium using an enormous funnel-shaped magnetic field ranging from kilometers to many thousands of kilometers in diameter. The hydrogen is compressed until thermonuclear fusion occurs, which provides thrust to counter the drag created by the funnel and energy to power the magnetic field. The Bussard ramjet can thus be seen as a ramjet variant of a fusion rocket. The Bussard ramjet was proposed in 1960 by the physicist Robert W. Bussard. That's all for today. See you soon.